So today what we'd like to do is we'd like to look at chain rule as one of its techniques of differentiation. But first, I'd like to give you this question. So here we have A over B times B over C. How can you simplify this? And some of you guys might be thinking, "How? This is very obvious." Yeah, I mean, I guess I don't even have to give you time to do this one because, as you know, B's will cancel out and becomes A over C. And you are correct. Now, for my next question is this: what if we had to do something similar on this way? dy over du times du over dx. In this case, this one is simply talking about simple multiplication, not the cross product in linear algebra or multivariable calculus. Now here we're simply looking at multiplication of these two. Then what are we going to get? Yes, the u's will simply cancel out, and we'll end up getting dy over dx. All right, now, wait a minute. That means if in order for us to find dy over dx, if y is in terms of another variable, dy over du, all I have to do is express u in terms of x and taking the derivative, then we'll end up getting this. Haha. In fact, this idea is chain rule. Now, let's try to put this one into an action. Next question. Number one. So what I'm saying is y equals sine of x entire thing squared. And how are we going to do this? And one way which we can do it is this one is equal to y equals sine of x multiplied by sine of x. So we could use the product rule, which we'll do on the side, and then we'll compare the answers and see if we do get the same answer or not. In order for us to calculate this one, what I like to do is maybe we'll try to use this portion as u. So we are looking at y equals u squared and u equals sine of x. So what if we have to assume this one? Now, then here we get dy over du equals, in this case, simply 2u. Now, how about u? Du over dx becomes cosine of x. Derivative of sine being cosine. Then, simply what we end up getting is this. By multiplying, just like earlier what we have done, by multiplying these two derivatives, dy over dx, that must be equal to 2 times u. U in this case was sine of x times du over dx, which is cosine of x. Alright, so that becomes our answer. Now, but if you have to look at this one carefully, you will realize that we could have done this one using the product rule. So then what do we have? Y prime is equal to this one, sine of x times the derivative of this, which is cosine of x, minus the other one, derivative of this, times this one times derivative of, plus, my bad, derivative of the other one becomes cosine of x. Then as you can see, we'll end up getting 2 sine x cosine x. So either we use the u substitution, meaning the chain rule, or simply using the product rule, we will end up getting the same answer. And as we know that this is equal to sine of 2x. We could write it in this way. That's perfectly fine. But one way or the other, you see the chain rule is all about identifying what u is. So let me try to get you another question. How about here? Number 2. For this question, I'm going to give you a little bit of time for you to do by yourself. And soon after, we'll try to work on it together. All right. So I'm gonna trust that you already have done this one, and let us try to look at this question together. What is the outer layer? The most dominating function seems to be the cosine, where x squared is 1 in the middle. So let us assume that as u. Then what do we end up getting? We will have y will be equal to cosine of u, where u equals x squared. And how are we going to find dy over dx? Just like earlier, we can figure out dy over du first, which will be equal to negative sine of u. Now, how about here? Du over dx simply becomes 2x. Then all we have to do is simply combine them together, where dy over dx is simply product of these two. So we have 2x times negative sine of u. What is u? X squared, which simplifies into negative 2x sine of x. That becomes our answer. All right, how about the next page? You see here I gave you two more functions, and then I want you to try to look at them. I'll give you a couple of minutes for you to finish, and then we're going to continue right after. All right. So let us look at these two examples here. We are looking for dy over dx, but as you can see, that we have square root, which seems to be the dominating expression, and then underneath of that we have this. So what if we assume the inside portion as u? That means we are looking at y is equal to square root of u, where u is equal to 2x minus 3x squared. Now, then what is dy over du? Dy over du. That will be, because this portion is equal to, let me just write it with another color, u to the 1/2 power. 1/2 comes out, becomes then u to the negative 1/2 power. Right? That's basically what we end up getting. And how about u? Du over dx becomes, here 2x becomes 2, and then minus 6x. That's what we end up getting. So therefore, dy over dx is simply the product of those two, which we end up getting 1/2, and u was this expression 2x minus 3x squared to the negative 1/2 power times 2 minus 6x. Now, once you simplify this one, what we end up getting is this. We will have 2 on the denominator, and then since due to the negative exponent, we will also have that on the denominator. We have 2x minus 3x squared, and in the numerator we have 2 minus 6x. Now, notice 2 is common here, so we can cancel this one out to be 1. This one is 1, and then this one is 3. So therefore, our final answer becomes 1 minus 3x divided by square root of 2x minus 3x squared. All right, there it goes. That's for number 3. How about number 4? Can you see that 1 minus 2x to the 4th power could be equal to u? So here we have y equals u to the 7th power, where u is equal to 1 minus 2x to the 4th power. Then here, what do we have? dy over du becomes 7 u to the 6th power. And here we have du over dx simply becomes negative 8 x to the 3rd. Now, of course, to find out dy over dx is simply the product of those two, which ends up being negative 56. U was equal to 1 minus 2x to the 4th, the 6th power, and multiplied by x cubed. So that becomes our final answer. All right. So with that, we'd like to close it for today and have a nice day. I'll see you later. Bye.